Hi everyone. In last session, we have discussed about Auber principle, then n plus L rule. Based on that, we have discussed about energies of different orbitals. By using energies of different orbitals, how to construct periodic table, we'll discuss today. So, construction of periodic table by using Auber principle and energies of various orbitals. According to Auber principle and Euler's diagram, this is the order of various orbitals. One is 2s2p, 3s3p, 4s 3d 4p, then 5s 4d 5p, then 6s 4f 5d 6p, 7s 5f 6d 7p. These are the different orbitals. How many? Total 19 orbitals are there to write electron configuration for all 118 elements in our periodic table. So by using this only we can construct a periodic table. So by using this Niels Bohr constructed modern periodic table. So already in last session only we have discussed everything. So first period, this is up to here, this first period. Every period starts with S orbital and ends with P orbital except first period. First period starts with S orbital and end with S orbital only. Remaining all periods starts with S orbital and end with P orbital. So that here this is the first period, this is second period, this is third period, up to here fourth period, up to here fifth period, this is sixth period, then this is seventh. In our periodic table, 7 periods and 18 groups are present. 7 periods and 18 groups are present. So here in this first period, S orbital only present. So S orbital can accommodate only 2 electrons. So that in S orbital period, otherwise this first period, only 2 elements are present. So that we can say this shortest period in the periodic table. So like that this is first short period. Total how many elements? 2s 2p. 2s 2p means in s orbital 2 electrons and p orbital 6 electrons. That means total electrons are 8 here. Here also 8. So first short period, second short period. This is first long period. This is second long period. These two are longest periods based on number of elements present in that particular period. See here 8, 8. Here 18. Here 18. Totally if you count here we get 32. Here also 32. So these two are longest periods. Otherwise this is the first long, second long. Otherwise the longest first, second longest. Like that we can say. They are the different periods. So how to construct periodic table by using this we'll discuss. Total how many periods are there? 7 periods are there. So periods are always in horizontal line and groups are vertical line. So here 7 periods I am writing here now. First this is the first period. This is the second period. This is third one, fourth, fifth, then sixth, then this is seventh. They are the 7 periods. So here 7 horizontal lines I am writing here. First period. This is the first period. Rough diagram I am giving. Then this is the first period. Then this is second period. This is third period. This is the rough diagram. Fourth period. This is the fifth period. Then sixth period. Then this is the seventh period. Total how many? 7 periods are there. There are the 7 periods. First, second, third, fourth, fifth, sixth, and seventh period. And first period contain only 2 elements. 2 elements means here see this is the first period. Total how many periods here? Is the first period. Total 18 periods we have. First one. Then this is the second. This is here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, here 18. There are the groups. 18 groups are present in our periodic table. See, this is the first period, first group. This is second group. This is the third group. This is the fourth group. Then fifth group, sixth group. then 7th group, this is the 8th group, this is the 9th group, 10th one, 11th group, then this 12th, 13th, 14th, 15th, 16th group, then it is 17th. There are 7 periods, and 18 groups. Vertical lines are groups. Horizontal rows are periods. How many? 1, 2, 3, 4, 5, 6, 7. So these are the periods and groups. Here these are, here I am putting G. This is G, this is P. These are the periods and these are the groups. How many groups are present? Total 18 groups are present. This is about modern periodic table, not other Mendeleev periodic table or different other periodic tables are there. This is only about modern periodic table. This was constructed by Niels Bohr by using Aubert principle and energies of various orbitals. And what is the one more statement you have to remember? Every period starts with s orbital and end with p orbital except first period. First period starts with s orbital and end with s orbital only. That means in first period only two elements are there present. First two elements. This is the first element in periodic table. This is the second element here. I am writing atomic numbers. First element, that is second element. Then third element, then here 4. Then after, see in this you can observe 2s, 2p. In this d orbital is not present. D orbital is not present, therefore we have to leave 10 boxes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then fifth element is present here. Fifth, then sixth, 7, 8, 9, 10. 10 elements. Then after 11 elements again come here in third period. 12th. Then again here also you can observe 3s, 3p. Start with 3s, end with 3p. In between these there is no d orbital. So that for d orbital there is a accommodation for 10 electrons. So that 10 electrons means 10 elements. 10 elements means 10 boxes here. We have to leave again 10 boxes from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 13th element is present here now. 13, then 14, 15, 16, 17, this is 18th element. Then 19th element come again into first group and fourth period. This is the 19th. Then 20. Then after here, this is the fourth period now. Fourth period means it will start with the s orbital and with p orbital, but in between these two, if you observe, there is a d orbital here. So d orbital related elements are starts from fourth period. So here 20, then we can write here 21, 22, 23, 24th element, 25th element, 26th, 27th, 28th. Means here we are arranging all the elements according to increasing order of their atomic numbers. According to their increasing order of atomic numbers. 28, then 29, then 30 it is. Then 31, 32, 33, 34th, 35th element, then 36th. Then after 36, next element, 37th element enter into 5th period. Then 38, then here 39, then 40, 41, 42, 43, 44, 45, 46, then 47. This is 48th element. Then 49 to 54, 50, 51, 52, 53, then 54. Then 55th element again enter into first group and sixth period. 55 it is. Then 56. Then here 57. This is important now. 57. This is important. After 57, we can expect here 58. But in sixth period, if you observe here, in sixth period, if you observe 6s orbital, then 6p orbital. But here, along with the 5d orbital, there is a 4f orbital also. These 4f 14 electrons are present, or 14 elements are present in this box only. But those 14 elements which starts from 58, 58, which are nothing but 4f series elements. 4f series elements 58, then 59, 60, 61, 62, 63, 64, 65, 66, then 67, 68, 69, 70, 71, up to 71 you can count from here 14 elements. 58 element atomic numbers, they are nothing but atomic numbers. 58 atomic number, 59, 60, 61 to 71 if you see here 14 it will be. So next element enter here 72, then 73, 74, 75, 76, 77, 78, then 79, then here 80. Then after 81, 82, 83, 84, 85, then 86. Similarly, 87th element occupy this first group and 7th period. 87, then 88, then this is 89. Here also again we have to remember this is 89 here 7th period. In 7th period it starts with s orbital, that means 70, 87 and 88 comes under 7s. Then after along with 6d orbital 5f orbital also present. Those 5f means again each 5f f orbital can accommodate 14 elements, otherwise 14 electrons. So that after 89 these elements are related to 5f series. 5f series this one. So in 5f series also here which element 89 means here 90 onwards. 90, 91, 92, 93, 94, 95, 96. 96, then 97, 98, 99, 100, here 101, 102, then 103. These are the atomic numbers. Here also if you count from here 90 to 103, it will be 14. So after 14 element, 104 element again enter here, 104. Then 105, 106, 107, 108, 109, 110, 111, 111, 111, 112, 113, 114, 115, then 116, 117, then 118. This is the last element in the periodic table. This is a simply construction of periodic table. See, now we will get shape of periodic table now. See here, these empty boxes I am removing. Empty boxes I am removing from here. See here, you will get structure of modern periodic table. This is the structure of modern periodic table here. See, you can observe now. This is the modern periodic table. After that, you can write names of these elements. Names of these elements. Up to 30 already I given with atomic numbers, and also in previous sessions I given atomic numbers and atomic weights also again up to 30. Remaining elements also if you have interest you can remember in future. Here first, this is the first group, otherwise first period here. First period contain first and second, only two elements, so that it is very short period. This is the second period. Second period contain how many elements? 1, 2 with respect to S block, only 2 S orbital. 2p means from here, you know, 2p means p orbital always can accommodate 6 electrons. So that this is totally p. From here you can count 1, 2, 3, 4, 5, 6. This means these 6 elements are present in p orbital. These two elements, two groups are present in s orbital. In the middle, 10 elements are present in d orbital. D orbital can accommodate 10 electrons. So that from here to here, third to 12th are present in d orbital. Then f orbital, 4f or 5f. Here we have how many? Total 14 elements in each series. 14 elements in each series. One is 4f series, because all those elements are related to 4f orbital. 4f orbital electrons there. 4f and other one is 5f. This is 4f. This is 5f. This is the construction of periodic table. Here you can observe up to here. Up to here, this is you can say S block. Because these two rows, these two vertical columns are present in s orbital. Only two elements means two electrons are present. First two electrons enter into s orbital, so that these are called as s block elements. Then from here you can observe from here to these are all these are up to here. These are the P block because 6, 1, 2, 3, 4, 5, 6, 6 vertical lines are present. Those are nothing but P block. In the middle, from here to here, you can observe. From here to here, these are nothing but D block. So this is D block here to here, and these two elements, first and second, are S block. These two are comes under S block. Then from here to there, this is P block, and from here to here, 14 elements are comes under F block. So this is simply construction of periodic table, which depends on only this order of energies. So here first period starts with only S orbital and with S orbital. So that here 1, 2. Then this is the second period. It starts with S orbital, 2s orbital and with 2p orbital. So here 2 elements with respect to 2s, then p, 6 elements are present here. Similarly 3s, 3p. This is third period. This is the third period. This third in third period 11th and 12 elements, then 13 to 18 which are present in p. Then fourth period you can observe here. This is fourth period. So here 19. How many elements? 4s2, 3d10, 4p, 6. 3d2, 4d, 10. 4s2, 3d10 means here 2 plus 10, 12 plus 6, 18. If you count from here to here, you will get 18 elements. So this is first long period. This also next fifth period. This is the fifth period. In fifth period also 37, 38 are comes under S block. 39 to 48 comes under D block, and remaining 49 to 54 comes under P block. Then after in sixth period particularly, this is the sixth period element. 6s 55, 56. 4f 58 to 71. Then 5d again 72 to 80. Then 6p 81 to 86. Then last period, seventh period. This is the seventh period. In seventh period, 87, 88. These two are S block. Then 89, next 92, 103. These are the F block, 5F series. Then 104 to 112, including 89. These are D block. Then 113 to 118. These 6 elements are present in P block. So this is the simply construction of periodic table. So for this, what you have to remember? First, in the beginning, we have to remember electron configuration of different elements. Electron configuration rules you have to remember. Auber principle first. Auber principle depends on n plus L rule. N plus based on n plus L rule, we can remember the order of energies. Otherwise, which orbital has more energy, which orbital has less energy. That we have to remember. Based on that, we have to write, we have to draw a diagram. Which diagram? Euler's diagram I given. Based on Euler's diagram, I written this order. 1s, 2s, 2p. This is the increasing order of different orbitals, increasing order of energies of different orbitals. Lowest energetic orbital is 1s. Highest energetic orbital is 7p. This is the increasing order. So this order only what I done, I split it in the middle. In what way? Based on Bohr's suggestion. What is the suggestion? In periodic table construction, we have to take first S orbital, lastly P orbital. Means starting with S orbital, ending with P orbital. One exception is there, that is first period. First period starts with S orbital and end with S orbital only. So like this, we can construct modern periodic table. So by using this, we can find a position of element in periodic table. For example, see what is the position of 10th element if they ask. What is the position of 10th element? Position in the sense we should say period number and we should say group number. 10th element. This here 10th element is there, no? What is the position of 10th element in the periodic table? It is comes under second period and 18th group. So if they ask what is the position of 31th element in periodic table, 31 atomic number, 31th element in the periodic table. So we have to search here. 31 is present here. See, this is the 31th element. 31th element comes under which one? Fourth period. And which group? 13th group. Fourth period and 13th group. Similarly, I need a position of 25th element in the periodic table. 25th element we have to search here. Here it is. 25th element. It comes under which period? Fourth period again. Fourth period again. Which group? Here. Seventh. It is very easy. Here see. Seventh means 2 plus 7. 25 is there no? 2 plus 7. Seventh period. Sixth period. 24. 2 plus 4 you can say. 6. 2 plus 3. 5. 2 plus 2. 4. 2 plus 1. It is 3. If it is here, see 11th, 2 plus 9, 11, but here it is not correct. 3 plus 0 is not correct, it is 12th after 11. Then we can say here it is different. So P block elements, D block element for S block elements and F block elements. We should know period and group, that is nothing but position. Position of element. Position means what? Position is nothing but first thing is block. Which block it is? Which block? S block or D block or F block or P block? In particular block, which period? Which period and which group? Which period and which group? This information is nothing but position in periodic table. This information is nothing but position in periodic table. So for that we have some rules. Means again no need to draw every time this total periodic table, and here it is not possible at all to say group number and period number by seeing this chart. But if you know writing electron configuration, we can get what is the position of periodic table in what is the position of the particular element in periodic table if you know electron configuration. So here we will discuss simply what is S block element, what is P block element, what is D block element, what is F block element. S block element is nothing but the elements in which electrons are present or electron enters into S orbital. P block elements are nothing but the elements in which last electron enters into NP orbital. D block elements are nothing but what? The elements in which last electron enters into N-1 D orbital, penultimate shell. F block elements are nothing but the elements in which last electron enters into N-2 F orbital. In next sessions, I will discuss what is S block, what is P block, what is D block, what is F block. I will give first definitions, otherwise statement related to different blocks, and particular element is present in which period and which group. Otherwise, simply what is the position of that element in periodic table we will discuss in next sessions. Okay, up to that, stay home, stay safe.